On November 5, 2018, a nervous, almost deathly silence reigned in the Mission Control Center at NASA's Jet Propulsion Laboratory in Pasadena. On the monitors, flickering with a greenish glow, lines of code streamed by, telemetry that had taken 16.5 hours to reach Earth. It was the signal from Voyager 2, the loneliest and most distant man-made object still functioning in normal mode. The engineers, many of whom had dedicated their entire lives to this project and had turned gray alongside it, looked at the graphs and couldn't believe their eyes. The plasma sensors, ancient instruments created back in the disco era and the Cold War, suddenly recorded a sharp, inexplicable spike. The surrounding temperature jumped to tens of thousands of degrees. Particle density rose abruptly. It seemed as if the probe, flying through the absolute frozen void at the edge of the solar system, had suddenly slammed into an invisible concrete wall, or entered the mouth of a volcano. But there were no volcanoes around, no stars, no planets, only eternal, impenetrable darkness stretching for billions of miles. At first, they thought it was a glitch. That would have been logical. The spacecraft had been operating in extreme conditions for over 40 years. Its computer memory is millions of times smaller than your smartphones. Its systems are worn out. Its generator is dying. But when the data was double-checked and compared with readings from its twin, Voyager 1, which had passed this way 6 years earlier, but in a different location, no doubts remained. It wasn't a glitch. It was a discovery. Voyager 2 had indeed crashed into something. It had hit the physical limit of our domain, the boundary where the sun's authority ends and the unexplored, hostile ocean of interstellar space begins. We are used to thinking of space as a void, as an endless nothing where you can fly in a straight line forever without meeting resistance. We look at the night sky and think the stars just hang there in a vacuum. But data received from the edge of our world shatters this illusion. The solar system is not open territory. We live inside a giant bubble, locked in from all sides. And the walls of this bubble are not a metaphor. They are raging, superheated plasma, a wall of fire and radiation that separates us from the galaxy. Today, we will take the most detailed, deepest dive into the history of this incredible journey. We will break down exactly what the Voyagers saw when they punched through this wall. Why do scientists call this zone a wall of fire? Where does a temperature of 30,000 degrees come from if there are no heat sources nearby? We will learn why the shape of our home actually resembles not a sphere, but a crushed croissant or a maimed insect. And finally, we will answer the main, terrifying question. What lies beyond this wall? Is it true that we are trapped in a local cage? And is there something looking at us from that darkness? Get comfortable. We are heading to a place where the sun doesn't shine, where compasses don't work, and where the concept of cold loses its earthly meaning. To understand the scale of what happened at the edge of the solar system in our time, we need to rewind the tape of history far back, to the middle of the 20th century. At that time, humanity was just learning to take its first tentative steps beyond the atmosphere. Rockets were exploding on the launch pad, satellites were falling, and no one was thinking about flights to the stars. But in 1965, a young intern at the Jet Propulsion Laboratory named Gary Flandreau made calculations that changed everything. He was plotting the orbits of the giant planets, Jupiter, Saturn, Uranus, and Neptune, and noticed an amazing pattern. Once every 176 years, these four giants align in one long, curved arc. It is a rare planetary alignment, and Flandreau realized that if a spacecraft were launched at that exact moment, in the late 70s, it could perform a grand tour. The ship could fly past all 4 planets in a single trip, using the gravity of each as a giant slingshot. A gravitational maneuver, or gravity assist, is a trick of celestial mechanics. When a ship approaches a planet, it sort of falls toward it, accelerating, but doesn't crash. Instead, it flies past, stealing a tiny bit of the planet's orbital energy. The planet slows down infinitesimally, by a fraction of a millimeter per century. But the tiny ship gets a massive boost, catapulting toward the next target. Without this maneuver, a flight to Neptune would take 30 years. With the planetary alignment, only 12. It was a 1 in a million chance. If NASA missed the launch window in 1977, the next opportunity would not arise until the year 2153. Neither you nor I would be around to see it. So, the decision was made instantly. We are going. The project was named Voyager. 2 twin spacecraft were built, Voyager 2 and Voyager 1. The names can be confusing. Voyager 2 was actually launched first, on August 20th, 1977. Voyager 1 followed on September 5th, but on a faster trajectory, so it was destined to overtake its brother. Let's take a second to visualize these machines. This is the pinnacle of 70s engineering. Each apparatus weighs 1,594 pounds. It has a large white dish antenna, 12 feet in diameter, to communicate with Earth. It has eyes, television cameras on a scan platform. It has ears, plasma wave receivers, and it has a heart, 3 radioisotope thermoelectric generators. These aren't solar panels. Where they were going, the sun shines no brighter than a distant star. Panels are useless there. So, the Voyagers run on the decay of plutonium-238. Spheres of red-hot plutonium release heat, which is converted into electricity. At launch, they generated 470 watts. That's less than your microwave consumes. And on this energy, the craft had to run a computer, heat instruments, turn cameras, and send a signal across the abyss. Now, think about the technology. The Voyager computer system has only 68 kilobytes of memory. 68 kilobytes. A single photo on your phone is thousands of times larger than the ship's entire memory. Data was recorded on an 8-track tape recorder. If the tape snapped or jammed, mission over. The transmitter has a power of 23 watts. That's the power of a light bulb in a refrigerator. And with this whisper, Voyager had to shout across billions of miles. The engineers built in an incredible safety margin. They duplicated systems, shielded cables with aluminum foil against interference, and used radiation-hardened parts. They built them as if the fate of humanity depended on it. And, as it turned out, they weren't wrong. The flight to Jupiter took almost 2 years. In March 1979, Voyager 1 approached the King of Planets. And what it transmitted shocked scientists. Before this, Jupiter had only been seen through telescopes as a blurry striped spot. Voyager showed it as a churning, dynamic world. It saw the Great Red Spot, a hurricane the size of 3 Earths that has been raging for hundreds of years. It saw complex atmospheric vortices spinning in opposite directions. But the main discovery awaited not on the planet itself, but on its moons. Io, a moon the size of our moon, turned out to be the most volcanically active body in the solar system. Before the eyes of astonished scientists, Voyager photographed volcanic eruptions spewing sulfur hundreds of miles upward. This overturned the idea that moons are dead rocks. It turned out Jupiter's gravity needs Io like Play-Doh, heating its insides. Then came Europa, a smooth ball of ice, crisscrossed with cracks, but lacking craters. This led scientists to the idea that a giant ocean of liquid water hides beneath Europa's ice. an ocean containing more water than all of Earth's seas and rivers combined. This was the first hint that life might exist not only on planets, but in the icy abysses of distant moons. Having received a powerful gravitational kick from Jupiter, the Voyagers raced toward Saturn. The rendezvous took place in 1980 and 81. Saturn, the Lord of the Rings. The Voyagers showed that the rings are not solid disks, but thousands upon thousands of thin threads consisting of ice chunks and dust. They saw shepherds, small moons that use their gravity to keep the rings in order. But it was at Saturn that the twins' paths diverged. NASA had a choice. Voyager 1 could fly to Pluto, but then it would miss Titan, Saturn's mysterious moon, the only moon with a dense atmosphere. Scientists decided to sacrifice Pluto for Titan. They directed Voyager 1 on a dangerous close approach. The probe passed just a few thousand miles from Titan, trying to see the surface through the thick orange haze. It didn't see the surface, but its sensors analyzed the atmosphere and found organics there. Methane, ethane, complex hydrocarbons. It was a factory of prebiotic chemistry. Titan turned out to be like a frozen Earth at the moment life began. After this maneuver, Voyager 1 shot sharply upward, perpendicular to the plane of the ecliptic. It finished its planetary mission. Now its path lay into the black void, away from all known celestial bodies. It became a lonely wanderer whose goal was simply to fly as fast and as far as possible. Voyager 2, however, continued the grand tour. Uranus and Neptune awaited it. In January 1986, it flew past Uranus. This is a strange, pale blue world that rolls along its orbit, lying on its side. Uranus looks like a calm, almost boring ball of gas, but its magnetic field turned out to be insane. It is offset from the center of the planet and tilted at a wild angle. Voyager discovered new moons and rings at Uranus that no one suspected existed. And finally, August 1989. Neptune, the last outpost, the most distant planet. Pluto was still considered a planet then, but it is small and far away. Neptune met Voyager with storms. Scientists saw the Great Dark Spot, an analog to the spot on Jupiter, a giant hurricane where winds blow at 1,200 miles per hour. These are the fastest winds in the solar system. Voyager flew past the moon Triton, where it saw geysers of liquid nitrogen. Imagine, minus 235 degrees Celsius, and fountains of nitrogen erupt from the ground, instantly freezing and falling as black snow. With this, the planetary part of the mission ended. Both spacecraft fulfilled their tasks 1,000%. They discovered dozens of new moons, explained the nature of rings, and showed us volcanoes and oceans where we expected only ice and rock. Logically, the program could have been shut down. Funding was cut. Many engineers retired or switched to new projects. But the Voyagers didn't die. Their nuclear hearts continued to beat. And then a new mission began. A mission that had no clear name, but had a great goal. The Voyager Interstellar Mission. The task: find the edge. Find where the sun ends. The 90s and 2000s became the time of the Great Silence. The craft were moving away from us at a speed of 10 miles per second. Communication became increasingly difficult. The signal weakened. To catch their voice, giant antennas of the deep space network on Earth had to be combined into a single system. All this time, they were flying inside the heliosphere. The heliosphere is the domain of the sun. Our star is not just a light bulb. It is a thermonuclear reactor that constantly spews millions of tons of matter. This stream is called the solar wind. It consists of protons, electrons, and alpha particles. This wind blows at speeds ranging from 200 to 500 miles per second. It inflates a huge bubble around the solar system, pushing back the interstellar medium. As long as the Voyagers were inside this wind, they were home. But scientists knew that sooner or later, the pressure of the solar wind had to weaken. It had to balance with the pressure of the interstellar gas pushing from the outside. This place of equilibrium is called the termination shock. This is the first barrier, the first line of defense of our system. Voyager 1 reached this line in December 2004. At a distance of 94 astronomical units from the Sun, that's 8.7 billion miles, its instruments showed that the solar wind slowed down abruptly. Before this, it was flying faster than the speed of sound. Plasma has its own speed of sound, and now it became subsonic. Imagine a supersonic jet braking hard. A shock wave is created. Compression. The plasma temperature rose, and the magnetic field became chaotic. Voyager entered the helioheath. This is the outer shell of the bubble, the flesh between the skin and the pit. Here the solar wind no longer blows smoothly. It churns, curls into vortices, and mixes with particles penetrating from the outside. This is a turbulence zone. Voyager 1 flew through this chaos for 8 long years. 8 years through a plasma storm. And then came the year 2012, a year that went down in history. Data from Voyager 1 started showing something strange. The number of particles arriving from the Sun began to drop, at first slowly, then in jerks, dropping, then returning. The craft was like a swimmer diving into waves at the ocean's edge. It was on the very brink. On August 25, 2012, all instruments recorded a final change. The solar wind disappeared completely. Zero. Silence. And instead, the sensors were swamped by a stream of galactic cosmic rays, particles of ultra-high energies, accelerated by supernova explosions and black holes somewhere deep in the Milky Way. Their intensity jumped manifold. It was the moment of truth. Voyager 1 had crossed the heliopause. It was out. But joy was mixed with confusion. The data didn't match theoretical models. Scientists expected that upon exiting into interstellar space, the direction of the magnetic field would change. After all, inside the bubble, the field is dictated by the Sun, and outside, by the galaxy. They should be pointed differently, but Voyager recorded no change in direction. The field strength grew. It became tighter, like a taut string, but the compass needle didn't waver. This spawned arguments for years. Skeptics shouted, "It hasn't gone anywhere. It's still in some strange pocket of the heliosphere." They invented the theory of a magnetic highway, that the solar and galactic field lines intertwined, creating a tunnel. Voyager was simply riding this tunnel, but was still in the foyer. Confirmations were needed. We had to wait for the second scout. Voyager 2 was lagging 6 years behind and flying on a different trajectory, further south. And when it reached the boundary in 2018, it put an end to the arguments. Its crossing was different. It was sharper, cleaner. In one day, the readings changed drastically. And, unlike its brother, Voyager 2's instruments worked better. It still had a working plasma spectrometer, which on Voyager 1 had broken back in 1980. Thanks to this functioning instrument, we were able to directly measure the temperature and density of the medium. And that is where the wall of fire was revealed. Voyager 2's instruments showed that immediately beyond the heliopause, the plasma temperature ranges from 30,000 to 50,000 degrees Kelvin. This seems absurd. Space is absolute zero, minus 273 degrees Celsius, right? Where does heat like that of a nuclear reactor come from? Here we need to take a deep breath and understand the physics. In space, the concepts of heat and temperature are separated. On Earth, if you stick your hand in an oven heated to 400 degrees, you get burned because the air is dense. Billions of molecules hit your skin every nanosecond, transferring energy. In interstellar space, the vacuum is almost perfect. There might be only 1 or 2 particles per cubic centimeter. Temperature in physics is a measure of kinetic energy, the speed of these particles. The particles beyond the heliopause zip around at insane speeds, so their temperature is formally high, tens of thousands of degrees. But because there are so few of them, they cannot transfer heat to the ship. If you stuck your hand out of Voyager, you wouldn't burn. You would instantly freeze. The ship continues to cool down, despite flying through scorching plasma. But why are they so fast? Where is the energy from? This is the result of a collision of worlds. The solar bubble doesn't just hang in the void. It moves, and it collides with the interstellar wind. At the point of collision, the plasma compresses and heats up. It's like the bow wave before a fast-moving ship. The Voyagers punched through this wave. This discovery proved our solar system is surrounded by a hot shell. We are like the yolk in an egg, surrounded by the white, and only then comes the shell. This shell plays a critical role. It serves as an additional filter. If it weren't there, the amount of galactic radiation reaching Earth would be even higher. This wall of fire burns out some of the dangerous particles, keeping them out. We should be grateful for this wall. The discovery of the wall of fire is just the tip of the iceberg. Data that the Voyagers and their colleague, the IBEX spacecraft, which scans the system's boundaries from Earth orbit, have transmitted over the last 5 years, has forced us to completely rethink what our home looks like from the outside. If you open old astronomy textbooks from the 90s or 2000s, you will see a picture where the heliosphere is depicted as a comet, a round head containing the sun and planets, and a long, long tail stretching for billions of miles behind, like the wake of a ship on water. It seemed logical. We are flying through the galaxy, so there must be a trail behind us. But reality turned out to be far stranger and more chaotic. In 2020, a group of astrophysicists led by Merav Ofer from Boston University, using new data from the Voyagers, built a refined 3D model of the heliosphere. And when the computer finished rendering, the scientists didn't see a comet. They saw a deflated croissant, or, if you prefer, a giant shrimp without a shell. Our heliosphere doesn't have a long tail. It is flattened. It has 2 short, curved jets in the back, with a gap between them. Why is the shape so ugly and irregular? Why does our protective bubble look like it was chewed on by a giant cosmic dog? The answer lies in the invisible battle of magnetic fields. The sun is not just a source of light and wind. It is a giant magnet. And since the sun rotates on its axis every 27 days, its magnetic field twists into a spiral. Imagine a ballerina's skirt spinning during a pirouette. This magnetic skirt stretches to the very edges of the system. But outside, there is also a magnetic field, interstellar, the field of the galaxy itself, and it presses on our bubble with monstrous force. It is this external field that crumples the tail of our heliosphere, preventing it from extending. It deforms our shield, flattening it from the sides. This discovery is frightening in its instability. We thought we lived in a perfect sphere, but it turns out we live in a pulsating, distorted bag that constantly changes shape under the blows of galactic waves. Moreover, this bag is leaky. The Voyagers discovered so-called magnetic reconnection. This is a process where the lines of the solar magnetic field break and connect with the lines of the galactic field. Holes form, tunnels, sort of cosmic highways along which matter can freely penetrate inside and exit outside. This means our quarantine isn't perfect. The galaxy is constantly tossing its substance to us, and we don't always know exactly what is flying into these open windows. Now let's talk about why the pressure outside is so strong. Why is the external environment attacking our bubble so aggressively? In 2020, while analyzing data from Voyager 2, scientists noticed another anomaly that defies intuition. How do we usually imagine space? The further from a star, the emptier it should be. Inside the system, there is a lot of dust, gas, solar wind. Outside should be a perfect vacuum, but the instruments showed the opposite. As soon as Voyager 2 left the heliosphere and flew a bit further, it recorded an increase in electron density. The plasma density outside turned out to be higher than inside in the rarefied solar wind. We didn't fly out into freedom, into the void. We flew out into a thick fog. We are like a submarine that surfaced from the depths, only to find that the water above is even denser. This confirms the theory that the solar system is currently passing through the local interstellar cloud. This is a giant accumulation of gas and dust, spanning about 30 light years. We flew into it roughly 40 to 60,000 years ago. In cosmic terms, literally yesterday. And we have yet to fly through it for another 10 or 20,000 years. Where did this cloud come from? It is remains. Ash. A graveyard. We live in a region of the galaxy called the local bubble. This is a huge cavity in the interstellar medium, hundreds of light years wide. This cavity formed millions of years ago as a result of a series of catastrophic supernova explosions. Imagine 10 or 15 massive stars exploded one after another, like a chain reaction of mines on a field. The shock waves from these explosions swept all the gas out of this region, creating a bubble of hot, rarefied gas. And the local interstellar cloud, through which we are sailing now, is the debris of those explosions, clumps of matter that didn't manage to scatter. This cloud consists of hydrogen, helium, dust, and traces of heavy elements born in the nuclear flames of dying stars. We are literally breathing the dust of our stellar ancestors. It is this cloud that creates the very pressure that compresses our heliosphere, turning it into a croissant, and creates the wall of fire at the boundary. We are flying through resistance. And this brings us to the most alarming scenario astrophysicists warn about: the galactic winter scenario. We are used to stability. It seems to us that the sun always shines the same, and the space around us is unchanging. But the solar system is a bullet flying at a speed of 143 miles per second around the center of the galaxy. And on its path, it encounters different weather conditions. Right now, we are in a relatively thin cloud. But what happens if we fly into a truly dense nebula? Voyager data allows us to model this. If the density of interstellar gas increases by 100 or 1,000 times, and there are such clouds on our path, the pressure on the heliosphere will become catastrophic. Our bubble will begin to shrink. First, the boundary that the Voyagers crossed at a distance of 120 astronomical units will approach the orbit of Pluto, then Uranus, then Saturn. If the compression continues, the heliosphere could shrink to the size of Earth's orbit. What does this mean for us? We lose our shield. Cosmic rays, lethal galactic radiation, dust particles, all of this will pour into Earth's atmosphere. This will lead to the destruction of the ozone layer. The radiation background on the surface will rise, causing mutations and cancer. The climate will change. Dust in the atmosphere will block the sun. Geologists find traces of iron-60 isotopes in Antarctic ice cores, that could not have appeared on Earth naturally. This iron arrived from space, from supernovae. This means that in the past, Earth has already lost its shield. And some scientists link these periods to epochs of global extinctions and ice ages, when our planet turned into a white ball of ice, the so-called snowball Earth. The Voyagers are our only sentries, our weather balloons. They are out there now, in the vanguard, checking the density of the environment. And for now, they signal to us. Density is rising, but it's tolerable so far. They let us know that straight ahead, there is currently no storm that could wipe out civilization. But we don't know what will happen after 1,000 years of flight. In 2021, continuing to listen to the ether around Voyager 1, scientists at Cornell University discovered another anomaly in the data, something that made them shiver. Usually, the interstellar medium is silent. Bursts of activity happen only when our sun ejects a coronal mass ejection. The shock wave from the sun rolls out to Voyager a year later, hits the plasma around it, and the plasma begins to ring like a bell. Instruments record a sharp squeak. But this time, the sun was calm. There were no ejections. Yet Voyager still heard a sound. It wasn't a sharp squeak, but a monotonous, constant, low-frequency hum. Imagine a quiet, barely audible rain drumming on a roof, or the sound of static electricity. This sound didn't stop. Scientists concluded, this is the voice of the plasma itself. Interstellar gas vibrates. It is in a state of constant, weak excitation. This discovery was revolutionary. It proved that the void beyond our system is not a dead silence. It is a living, dynamic environment where processes unknown to us are taking place. Voyager hears the breathing of the galaxy. This hum is very faint, on the edge of the instrument's sensitivity, but it is there, and it is everywhere. This changes perception. We are not hanging in a void. We are floating in an ocean that makes noise. And this noise tells us about pressure, about hidden energy that permeates the space between stars. Now, let's destroy the most popular myth associated with the Voyagers. You've probably seen news headlines. Voyager has left the solar system. It sounds proud. Man has conquered gravity and broken out of his home. But astronomers only shake their heads sadly at these words. Technically, the Voyagers have left the heliosphere. They have exited the zone of solar wind. They stepped over the threshold of the house. But they haven't even reached the garden gate. The gravitational boundary of the solar system is monstrously far away, and realizing this scale causes real vertigo. Imagine our solar system as a football field. The sun is a small coin in the center. Earth is a grain of sand a couple of inches away from it. Neptune's orbit is roughly the penalty box. The Voyagers are now somewhere on the goal line. They have covered only this distance. But the sun's gravitational domain is not the football field. It is the entire city containing the stadium. Far beyond the orbits of the planets, in the cold darkness, lies the Kuiper Belt, a collection of icy bodies to which Pluto belongs. The Voyagers are already inside it. But even further begins the Oort cloud. This is a giant, spherical shell consisting of trillions of icy comets, slowly drifting around the sun, barely held by its gravity. This is the real edge. Let's translate this into numbers that make you feel uneasy. The distance from Earth to the sun is 1 astronomical unit, AU. Voyager 1 has flown 162 astronomical units. But the inner edge of the Oort cloud begins at a distance of 2,000 astronomical units, and the outer edge ends at 100,000 astronomical units. Do you understand? It flew 160. It needs to fly 100,000. If Voyager maintains its current speed, and it will, Since there is no friction in space, it will take another 300 years just to reach the beginning of the Oort cloud. And to fly through it and truly, finally, irrevocably leave the solar system, breaking free from the sun's gravity, it will take 30,000 years. 30,000 years. Let's look at this time frame in context. 30,000 years ago, Neanderthals still lived on Earth. Homo sapiens were just beginning to draw on cave walls. There were no pyramids, no wheel, no writing. And that is how much time must pass in the future for this little piece of metal to break free. By the time Voyager exits the Oort cloud, humanity might disappear. Our cities will turn to sand. Our languages will be forgotten. Perhaps we will evolve into cyborgs or destroy ourselves in a nuclear war, and it will still be flying. In total silence, among blocks of ice, in absolute darkness. This is a real prison. We are not locked in by a plasma wall. We are locked in by space. Distances in space are the most reliable jailer. Even light takes more than a year to reach the Oort cloud. And the nearest star, Proxima Centauri, is 4 light-years away. For Voyager, the flight to the nearest star will take 40,000 years. And by the way, it's not flying to Proxima. Voyager 1 is heading toward the constellation Ophiuchus. In 40,000 years, it will pass at a distance of 1.7 light-years from the star Gliese 445. Pass by. It won't stop. It won't enter orbit. It will simply drift through the system and fly on into infinity. Voyager 2, in the same 40,000 years, will pass by the star Ross 248, and in 296,000 years, by Sirius, the brightest star in our sky. Imagine, almost 300,000 years of flight. During this time, geological epochs on Earth can change. Continents will shift, and it will still be flying. This is a level of loneliness that the human brain is incapable of processing. We have created things that are immortal compared to us. And this brings us to the final, most touching and philosophical part of our story. To what exactly these ships carry. But before talking about eternity, let's return to the now. Right now, at this second, the Voyagers are dying. It is a slow, agonizing death from exhaustion. Their power sources, radioisotope generators, are inevitably degrading. The plutonium decays, there is less and less heat, the thermocouples wear out. We lose about 4 watts of power a year. It seems like a little, but when every watt counts, it's a death sentence. Now there is less than 250 watts left on board. This is no longer enough to power all systems. NASA engineers have to play a cruel game. They are forced to choose which organ to amputate so the brain can continue to live. First, they turned off the cameras. The Voyagers went blind back in the 90s. No more photos. It was painful, but necessary. The cameras consumed too much. Then they started turning off the heaters for the scientific instruments. It was a huge risk. The instruments are designed to work at positive temperatures, or at least a slight freeze. Without heaters, the temperature inside the casing dropped to -50, -60 degrees Celsius. Everyone thought the instruments would die. Lubricants would freeze. Circuit boards would crack. But, to the amazement of the creators, the cosmic ray and plasma detectors continued to work. They turned into frozen zombies, functioning contrary to all operating instructions. This is a testament to the genius of the engineers of the 70s. They built for the ages. But you can't cheat physics. Energy continues to fall. In 2023, NASA applied a hack. They sent a command to Voyager 2 to bypass the voltage regulator protecting against power surges. This allowed the use of a small reserve of energy kept for emergencies. It's like drinking the last canteen of water in the desert. This will extend the life of the instruments for another couple of years, until 2026. And then the rolling blackouts will begin. First, the plasma detector will go silent. Then the magnetometer. Then the low-energy particle detector. It is expected that by around 2030, 2032 at the latest, the last scientific instrument will be powered down. Voyager will cease to be a scientific tool. It will stop feeling space. But it will still be alive. Its transmitter will work. It will send Earth only a carrier wave, a simple signal, I am here, I am alive. Then there won't be enough energy even for that. The transmitter will go silent. Or, more likely, the ship won't have enough energy to keep the antenna pointed exactly at Earth. The beam of connection, thin as a needle, will drift away, and we will lose it forever. It will become a dead piece of metal drifting among the stars. But actually, it is at this moment that its main mystical mission will begin. Mounted on the side of each craft, in a visible spot, is an aluminum cover. And beneath it lies an object that has become a legend. The Voyager Golden Record. It is a 12-inch disc made of copper, coated in gold to protect it from cosmic corrosion for billions of years. Packed with the record are a stylus and a cartridge for playback, and etched on the cover are instructions, a language based on physical constants that any advanced civilization should understand. The transition frequency of the hydrogen atom, a map of our sun's location relative to 14 pulsars. What did we decide to tell the universe about ourselves? If you found this disk in 1,000,000 years, what would you think of the creatures that created it? The selection of materials was handled by a committee led by the legendary Carl Sagan. They had only a few months to compress all the history, culture, and biology of Earth into one copper disc. There are 118 photographs on the record, but these aren't digital files. It is an analog signal, encoded as sound. To see the pictures, aliens, or future humans, will have to spin the disc and decode the sound waves back into images. There are photos of the planets of the solar system, diagrams of human anatomy, a man and a woman, though NASA forbade sending them naked due to Puritan censorship of the 70s, so they are just silhouettes. There are photos of food, architecture, animals, a plane, a train, an X-ray. But the most important thing is the soundscape of Earth. The authors recorded sounds we have stopped noticing, but which define our lives. The noise of rain and wind, the crackle of a burning fire, the roar of a train, the sound of a kiss, a baby crying and a mother's soothing voice, a dog barking. There are greetings in 55 languages, from ancient Sumerian and Hittite to modern Russian, English, and Chinese. Brief phrases. Greetings to you, whoever you are. We wish you peace. And, of course, music. Music is the universal language of emotion. The choice was agonizing. How to choose 27 tracks to represent all of humanity? There is Bach and Beethoven, Mozart and Stravinsky, but there is also Louis Armstrong's jazz, Blind Willie Johnson's blues, Chuck Berry's rock and roll, Johnny B. Good. There is folk music, pygmy songs from Africa, Peruvian panpipes, Azerbaijani mugam, the Georgian choral song Chakrulo. It is an eclectic, strange, but incredibly lively playlist. But there is something even more intimate on the disc. Anne Druyan, the project's creative director and future wife of Carl Sagan, suggested recording the electrical activity of a human brain and heart. She hooked herself up to an EEG machine and recorded her thoughts. She thought about the history of Earth, about the atrocities of the Nazis and poverty, but also about love. At that moment, she had just realized she was in love with Carl Sagan. And this electrochemical imprint of a brain in love is now engraved in gold and flying through the interstellar dark. It is possibly the most romantic gesture in history, an electrochemical signal of love that will outlive Earth itself. However, this medal has a flip side, a dark side. Etched on the cover of the disc, besides the playback instructions, is a map. It is a pulsar map. In the center is the Sun. Rays radiate from it to 14 pulsars, neutron stars that spin at frantic speeds and emit radio pulses with the precision of atomic clocks. Next to each ray, the frequency of the pulsar is encoded in binary. Knowing these frequencies, any advanced civilization could find these beacons in the galaxy, and by triangulation, calculate the exact coordinates of the solar system. Moreover, since pulsar frequencies change slowly over time, they could calculate the exact date. The ship was launched. We literally drew an arrow. We are here. We live here. Come visit. Many scientists, including Stephen Hawking, criticized this decision. They called it madness. Hawking warned, meeting an advanced civilization could be like Native Americans encountering Columbus. That didn't turn out so well. We operate on the presumption of innocence, that higher intelligence must necessarily be kind and humane. But evolution on Earth teaches us otherwise. The strongest survive. The predator eats the prey. And a technologically more advanced civilization always absorbs or destroys the less advanced one upon contact. Here we approach the dark forest theory, described by sci-fi author Liu Cixin, but grounded in serious science within the Fermi paradox. Imagine the universe as a dark forest. Every hunter prowls silently, trying not to reveal themselves because there are other hunters in the forest. If a hunter sees movement, he shoots without hesitation to eliminate a potential threat. In such a forest, silence is the key to survival. Shouting, "I am here," is suicide. Perhaps that is why space is silent. Not because there is no one there, but because everyone else is smart enough to stay quiet. Everyone who shouted has already been destroyed. And us? We just sent 2 shiny devices with the exact coordinates of our home straight into the thicket of this forest. And added to that radio signals that we have been thoughtlessly broadcasting into space for 100 years. The Voyagers are our naive, childish attempt to make friends. We reach a hand out into the darkness, hoping it will be shaken, not bitten off. But what's done cannot be undone. Voyager 1 cannot be stopped. It is flying at 10 miles per second away from us. The map is sent, and even if it was a mistake, it was a magnificent mistake. A mistake born of hope, not fear. On February 14, 1990, when Voyager 1 had already finished its primary mission and was flying toward the edge of the system, it was at a distance of 3.7 billion miles beyond the orbit of Neptune. Carl Sagan persuaded NASA to take one last picture. It was technically difficult. They had to turn the camera platform backward, toward the sun. There was a risk that the bright light of the sun would burn the optics. Engineers resisted for a long time. Why waste precious time and resources on a photo of the void? Nothing can be seen there anymore. But Sagan insisted, and Voyager took a series of shots that formed the family portrait of the solar system. In one of these shots, in a scattered ray of sunlight reflected off the camera optics, a tiny, barely visible dot is seen. The size of this dot is less than a pixel, 0.12 pixels. That is Earth. Looking at this image, Sagan wrote words that became, perhaps, the most powerful philosophical manifesto of the space age. Listen to them. Imagine this picture: a vast, grainy void and a tiny speck of dust. Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. This photograph destroys our ego. Think of the rivers of blood spilled by all those generals and emperors so that, in glory and triumph, they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner, how frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Voyagers gave us not only scientific data about plasma and magnetic fields, they gave us a mirror. They flew so far away so that we could turn around and for the first time truly see ourselves. See how fragile we are. The wall of fire at the border of the system protects this dot, but it also isolates it. We are alone, at least for now. What awaits them next? As we said, in a few years they will go silent forever. Their thermal hearts will cool. They will turn into icy blocks of metal. But in space, death is not the end. It is a transition to another state. In a vacuum, there is no oxygen to oxidize metal, no moisture to cause rust, no wind to wear down the surface. The only enemy is micrometeorites and cosmic dust. They will slowly, atom by atom, erode the hull of the Voyagers. But this process will take millions of years. The golden record is under an aluminum cover. It is reliably protected. Calculations show that erosion will not erase the information from the disk until 1 or 2 billion years from now. A billion years. In a billion years, the sun will become 10% brighter. Oceans on Earth will begin to boil away. Life on the surface will become impossible. Our planet will turn into a scorched desert, like Venus. Humanity will likely be long gone. Either we will have left for the stars, or we will have disappeared, and the Voyagers will still be flying. They will outlive our civilization. They will outlive our biosphere. They will outlive even the sun itself. In 5 billion years, the sun will swell into a red giant, swallow Mercury, Venus, and probably Earth. And then it will shed its shell and turn into a dim white dwarf. The solar system will die, and the Voyagers will be far away. They will be making orbit after orbit around the center of the Milky Way galaxy. One orbit takes 225 million years. They will become eternal monuments to the fact that once, near a yellow star, lived a civilization that managed to overcome gravity. That was brave enough to send a message into nowhere, and loving enough to include the sound of a kiss in that message. Maybe, billions of years from now, when the galaxy is completely different, some alien ship will intercept this strange, ancient artifact. They will bring it on board. They will see the diagram. They will place a stylus in the groove. And in the silence of their cabin, a voice in a dead language will speak. Greetings from the children of planet Earth. And the music of Chuck Berry will play. And we will be alive again. At least for those 90 minutes while the music plays. The story of the Voyagers is not just a story about technology. It is a story about overcoming boundaries. First, we overcame Earth's gravity. Then we overcame the asteroid belt. Then we overcame the sun's pull. And finally, we overcame the boundary of the heliosphere, that very wall of fire. We are humans. We are explorers. We feel cramped within any boundaries. Right now, as you watch this video, Voyager 1 is at a distance of over 15 billion miles from us. A radio signal takes 22.5 hours to fly from there. The light you see from the stars is ancient, but the darkness Voyager flies through is even older. It is blazing a trail. Perhaps someday, thousands of years from now, ships with warp drives will follow in its tracks, and the passengers of those ships, flying past the coordinates where the ancient probe drifts, will salute it. But there is one question that gives us no peace. If we were able to send ships beyond our bubble, if we were able to announce ourselves, why hasn't anyone done this before us? Why, despite the billions of stars in our galaxy alone, did the Voyagers encounter only silence and plasma? Where is everybody? Why is the dark forest silent? And is there really someone there in the dark? Or are we the only intelligent beings for millions of light years, locked in the crumpled croissant of the heliosphere? This question, the Fermi paradox, deserves a separate, deep, and frightening conversation. And that is exactly what we will talk about in the next video. We will break down theories that make your blood run cold, from the zoo hypothesis to the great filter. If you don't want to miss this analysis, subscribe to the channel and hit the bell. And for now, look at the night sky and remember that there, in the infinite distance, flies a little piece of us. Thanks for watching.